Interruption to the video there. In this problem you have a heating curve. It wants to know where on the graph is a substance with definite shape and definite volume present. Well, something with a definite shape and a definite volume is a solid. So down here is where you have your solid, here's where you have liquid, here's where you have gas. Now in this case this problem is a little bit tricky, trickier than I would want to make the problem. But down here you have solid. At step 2 you have both solid and liquid present, so both 1 and 2 are valid answers. So the correct answer is B. And 17. Now I probably wouldn't count it wrong if you just put A, but I'm not going to ask a question exactly like this on the test. 10 grams of water undergo a temperature change from 15 to 0 degrees Celsius, which explains what has occurred. And it's talking about heat energy. So we've got a temperature change and heat, Q equals MC delta T. So Q equals, our mass is 10 grams times 4.18 is the specific heat of water, and our temperature change is 15 degrees. It'll be 627 joules. Now if the water is cooling down, is it losing energy or gaining energy? Well, if it gained energy, the water would get hotter. Since it's getting colder, it's losing energy. The answer is B. 18. 50 grams of iron at 298 kelvins is placed into 250 milliliters of water at 363 kelvins in an insulated container, which best describes and explains what will occur. Kinetic energy is essentially saying temperature. Well, the temperature of the water increases, heat's transferred from the iron to the water. Well, the iron is colder than the water. So is heat going to go from the iron to the water? Probably not. Will the kinetic energy of the water decrease as heat goes from the water to the piece of iron? Yeah, because the water is warmer than the iron. So the water is going to cool down while the iron heats up. So the answer to 18 is B. Keep in mind that it's heat that moves, not the stuff called cold. Yeah. Number 19. The boiling point. That's the point where it goes from liquid to gas. This is liquid on our graph. This is gas. This is solid. The boiling point, well, boiling happens right here. So our boiling point is going to be 140 degrees Celsius, which is C. Number 20. How many grams of liquid water at its boiling point can be vaporized if 5.5 times 10 to the third joules of heat is added? So this is being vaporized, so it's heat of vaporization, obviously. So 5.5 times 10 to the third joules equals how many grams times the heat of vaporization constant, 2260 joules per gram. The mass would equal 5.5 times 10 to the third divided by 2260, which is 2.43 grams, or A. Number 21 is not a good question. We're going to skip that one. 22 is a specific heat problem. The answer is C. 23 is a specific heat problem as well. The answer is B. You're using Q equals MC delta T, except you're going to use the specific heat of iron, 0.449. So you take the mass times the specific heat of iron times its change in temperature, which is a change of 1,510 degrees Celsius. 24. Which substance will require the most heat to raise 100 grams of the substance by 100 degrees Celsius? Well, if we're using Q equals MC delta T, if the masses are the same and the temperature change is the same, the one that requires the most heat would have the biggest specific heat. So out of aluminum, iron, magnesium, and lead, the one with the largest specific heat is magnesium. So the answer to 24 is C. For 25, we're doing a specific heat problem where they're telling us what Q is, 5.15 times 10 to the 4th joules, and we're told that the mass of water we don't know. The specific heat of water is once again 4.18 joules per gram degrees Celsius, and the change in temperature is 75 minus 15 or 60 degrees. You multiply all that out and you get 205 grams, which is B. In problem 26, if ice thaws from solid to liquid state during which the temperature of the ice-water mixture did not change, what is true? Well, it's going to involve a heat flow. The heat is not going from the ice into the surroundings. That would not make sense because the ice is colder. Heat only flows from hot to cold. So heat must be going from the surroundings into the ice. D. 27. Indefinite shape, indefinite volume, easily compressed. Well, heterogeneous is not even a state of matter. That's not a solid, it's not a liquid, that's a gas. And 28, we're just going to ignore that problem. All right.